In this lecture, we will be discussing about the various types of ventilation techniques used in electrical machines. So what do you mean by ventilation? Is ventilation similar to cooling, or if there is any difference between ventilation and cooling? Let us see. So cooling can be defined as the process of removing excess heat from the machine parts. So this heat removal process, that is cooling process, can be done in many ways. By passing air stream through the machine, by using some liquid coolant, etc. So if this heat removal process is done by means of passing air stream through the machine, then it is known as ventilation. So ventilation is the process of cooling of the machine by passing air stream through it. So now, classification of ventilation. Ventilation can be broadly classified into three types: natural ventilation, self-ventilation and separate ventilation. So natural ventilation is the process of ventilation in which the cooling is done by means of natural flow of air through the machine. So we are not using any supporting system for airflow to make air to flow into the machine. So here air naturally will flow into the machine and cool it. So these two categories, that is self-ventilation and separate ventilation, requires a fan for aiding or increasing the amount of ventilation. In self-ventilation, the fan is connected within the machine, that is within the end shield of the machine. Whereas in separate ventilation, a separate fan is used, that is the fan is connected outside the end shield of the machine. So that is separate ventilation. So now these two, that is self-ventilation and separate ventilation, can again be classified into two types. Self-ventilation is classified as induced self-ventilation and forced self-ventilation. So separate ventilation is also having the same classification: induced separate ventilation and forced separate ventilation. So self and separate ventilation are classified as induced and forced ventilation. So now let us check what is meant by induced ventilation and forced ventilation. So first, the induced ventilation. So in induced ventilation, the fan creates a reduced pressure of air inside the machine. So we know both self and separate ventilations requires a fan, either inside or outside the machine. So this fan will create a reduced air pressure inside the machine. And we know air is always having a tendency to flow from a region of high pressure to a region of low pressure. So when there is a low air pressure inside the machine, the outside air enters into the machine. So the air is sucked into the machine under external atmospheric pressure. The air is then pushed out by the machine into the atmosphere. So the air entering into the machine will flow through the various machine parts, carries away heat from those parts, and finally the air is pushed out to the atmosphere by the fan. So this is induced ventilation using an internal fan, that is induced self-ventilation. And this is induced ventilation using an external fan, that is induced separate ventilation. So air enters into the machine, cools the machine parts, and it is pushed out to the atmosphere by the fan. So next one is the forced ventilation. In forced ventilation, the fan itself sucks in air into the machine, and then the fan makes the air to flow through the various machine parts and carry away the heat, and finally the air is pushed out to the atmosphere. So see, air enters into the machine through this way, that is through the fan, and then fan directs air to the various machine parts, and finally it flows out of the machine. So this is the cross-sectional view of a rotating machine. So this is the shaft of the machine, and connected to the shaft it is the rotor, and this is the stator, the stationary part, and in between the stator and rotor we have the air gap. So this is our fan, and this is forced ventilation using an external fan, that is a fan connected outside the machine, which is known as forced separate ventilation. So now let us see some factors about induced and forced ventilation. This ventilation, induced self-ventilation. Induced self-ventilation is commonly used in small and medium power output machines. And we have seen that in induced ventilation, air enters into the machine, cools the machine parts and then leaves the machine through the fan. So fan is located at the leaving end. Air flows over the fan when it is leaving the machine. But in case of forced ventilation, air is entering into the machine through the fan. So as this fan is rotating, some rotational losses will be there, which is generated as heat. So that rotational losses will be in the form of heat. So this fan will be heated, and as the air flows through it, the air also gets heated. So hot air is entering into the machine in case of forced ventilation. So in forced ventilation, air entering into the machine is hot. So consequently, the heat transfer capability of the air decreases. So less heat can be removed by this hot air. As a result, the amount of cooling air required for properly cooling this machine increases. As the heat transfer capacity of the incoming air is less, more and more air, more quantity of air is required for properly cooling this machine. So that is said here. Amount of air required to cool the machine is higher with forced ventilation. So forced ventilation air enter cheyyunnathe fanil koodiyanu. So it is get heated due to the losses in the fan. So we need more air to cool the machine. So now regarding this fan, we know that as the fan rotates, noise will be produced. So fan is a major source of noise in the machine. So we know noise is undesirable. We have to reduce it. So in case of self-ventilated machines, that is where the fan is located within the end shield, in order to reduce the noise, the outside diameter of the fan should be considerably less than the inside diameter of the end shield. So we know the fan is located within the end shield of the machine. So in order to reduce the noise, the outside diameter of this fan should be considerably less than the inside diameter of the end shield. That means there should be considerable clearance between the fan and the end shield. So if fan is designed so, the noise can be reduced to a large extent. Now, so that means the outside diameter of the fan should be less. That means we have to use a small fan. If that fan is small, that means that the temperature rise in that machine should also be less. Then only we can use a small fan. Like ഒരു ചെറിയ ഫാൻ യൂസ് ചെയ്യണമെങ്കിൽ ടെമ്പറേച്ചർ കുറവാണെങ്കിൽ മാത്രമേ നമുക്ക് ആ ചെറിയ ഫാൻ യൂസ് ചെയ്യാൻ പറ്റത്തുള്ളൂ. സോ ഫോർ ദാറ്റ് ദ മെഷീൻസ് ലോസസ് ഷുഡ് ഓൾസോ ബി ലെസ്. ലോസ് കുറയുമ്പോഴാണ് ടെമ്പറേച്ചർ റൈസ് കുറവാകുന്നത്. സോ ഫോർ ദാറ്റ് മെഷീൻസ് ആർ ഡിസൈൻഡ് വിത്ത് സ്മോളർ സ്പെസിഫിക് ലോഡിങ്സ്. Specific loadings is nothing but the loading per unit area. Loading per unit area is known as specific loading. We have to study it in detail in the coming modules. So for instance, just understand it as loading per unit area. So as the loading of the machine decreases, its losses will also decrease. So losses less means temperature rise will also be less. So we can use a smaller fan. So now there is another classification for ventilation, and this classification is based on how the air passes over the heated machine parts. Depending on how the air passes over the various machine parts, ventilation can be classified into 3 types. They are radial ventilation, axial ventilation, and combined axial and radial ventilation. So now let us see each of these types. So first one is the radial ventilation. So this radial ventilation is the most commonly used ventilation technique because as the rotor rotates, there is a centrifugal force created. So this centrifugal force causes a natural movement of air into the machine. The rotation of the rotor creates a natural centrifugal movement of air into the machine. And the end shields of the machine are constructed in such a way that it guides air. It makes air flow into the machine. It guides air into the machine like this. So this is the shaft of the machine and these are the end shields. So this is the elevation of the machine. So these are the end shields. So end shields guides air into the machine. Then there will be fans. Fans can also be used for increasing the ventilation process. So air then flows through the fans and with the help of the fan, air is guided to the overhang. These are the overhangs. This is one overhang. This is one overhang. So air then flows through the overhang and then to the back of the core. Then it leaves the machine through the back of the core. And this type of ventilation is used in machines having a rating up to 20 kilowatt. So this is a radial ventilation system used for smaller machines. That is machines having a smaller core. So this system is used for smaller core length machines. So natural centrifugal movement of air into the machine. The air is then guided towards the overhang and then to the back of the core. Now what is overhang? So do you know what overhang is? Overhang is nothing but the portion of the conductor which is outside the slot. നമുക്കറിയാം സ്ലോട്ടിനകത്താക്കിയാണ് വൈൻഡിങ്ങിനെ നമ്മൾ വൈൻഡ് ചെയ്യുന്നത്. But there will be some portion of the conductor which is remaining outside the slot and that is known as the overhang. So these are the overhangs. So now we have to see the radial ventilating system used for machines of larger core length. So in larger machines, that means machines with larger core length, the core is subdivided into different stacks. And each stack will be having a thickness in between 40 and 80 mm. The entire core is divided into different stacks of 40 to 80 mm thickness and ventilating ducts of 10 mm width are provided in between the stacks. So various stacks will be there like this and ventilating ducts are provided in between the stacks. So we know that in rotating machines, the stator as well as rotor cores are made up of laminations. There are a number of laminations and by stacking together these laminations, a core is formed. So how to divide this core into different stacks? So while arranging the laminations, after getting a thickness of about say 40 mm, we will place a spacer. Thereafter, on top of this spacer, we will again arrange the laminations to get a thickness of say 40 mm. Then again place spacer like that. So when a spacer is placed in between the laminations, there will be a gap in between these laminations. And this gap acts as a radial ventilating duct. So this is how radial ventilating ducts are formed in machines, rotating machines. So this can be done both in the stator as well as in the rotor. So radial ventilating ducts. So usually these ventilating ducts are having a width of 10 mm. So these are radial ventilating ducts. And air entering into the machine through the end shield will flow through the radial ventilating ducts also. So it can properly cool the core of the machine. So core inde edakudiyana pass cheyyunnathu. So it can cool the core. So now, we have said that this radial ventilating duct will be having a width of 10 mm. So when air is flowing through this ventilating duct of 10 mm width, only a layer of the ventilating duct, a 3 mm layer, wide layer, which is in contact with the core wall, is effective in cooling. So, രണ്ട് സ്റ്റാക്കിൻ്റെ ഇടയ്ക്ക് കൂടി 10 mm വൈഡ് ആയിട്ടുള്ള ഒരു ഏരിയയിൽ കൂടി എയർ ഫ്ലോ ചെയ്യുമ്പോൾ ഈ കോറിന് അടുത്തുള്ള ഒരു 3 mm ലെയറിൽ കൂടെ പാസ് ചെയ്യുന്ന എയർ മാത്രമേ കോറിൻ്റെ വാളിനെ കൂൾ ചെയ്യുന്നുള്ളൂ ഓൺ ബോത്ത് ദ സൈഡ്സ്. ആൻഡ് ദ മിഡിൽ 4 mm വൈഡ് ബാൻഡ് കോൺട്രിബ്യൂട്ട്സ് വെരി ലിറ്റിൽ ടു കൂളിംഗ്. ദാറ്റ് ഇസ് ആ മിഡിലുള്ള 4 mm വൈഡ് ആയിട്ടുള്ള ബാൻഡിൽ കൂടി ഫ്ലോ ചെയ്യുന്ന എയർ ആ കോർ വാളിനെ കൂൾ ചെയ്യുന്നില്ല. ബിക്കോസ് കോർ വാളിലേക്ക് അടുത്ത് കിടക്കുന്ന ആ റീജിയൻസിൽ കൂടെ ഫ്ലോ ചെയ്യുന്ന എയറാണ് കോർ വാളിനെ കൂൾ ചെയ്യുന്നത്. So that middle 4 mm wide band is actually useless. Some of the manufacturers now manufactures radial ventilating ducts having a width of about 6.5 mm. 6.5 mm wide ventilating ducts are being manufactured by some of the manufacturers. So in a radial ventilating system used for larger machines, the core is subdivided. The laminations are divided into different stacks and radial ventilating ducts are provided in between the stacks. And these radial ventilating ducts are 10 mm wide. And when air is flowing through this radial ventilating duct, what happens? Only the air flowing closer to the core wall helps to cool the core wall on both the sides of the duct. That is, the air flowing through a region which is 3 mm wide and near to the core wall cools this side of the core wall, and through the other side also a 3 mm wide band near to the core wall helps to cool this core wall. And the middle 4 mm wide band is actually useless, and we need only 6 mm wide area. Some of the manufacturers produces 6.5 mm wide ventilating ducts. So air flows through all the machine parts, it flows through the ventilating ducts and leaves the machine. Here, the path of the air through the ventilating ducts is parallel to that over the overhang. The air path through the overhang and air path through the radial ventilating ducts are parallel to each other. So now let us see what are the advantages and disadvantages of radial ventilation. So the advantages. First one, minimum energy loss for ventilation. So we have already said that in radial ventilation, due to the centrifugal movement of the rotor, air can naturally enter into the machine. So we have to spend very less energy for ventilation process. So next one is sufficiently uniform temperature rise in axial direction. So air is uniformly entering from both the sides. So temperature rise in the axial direction will be uniform. Now the disadvantages. It makes the machine length larger. So in case of large core length machine, the core is again subdivided and spaces are provided in between. This increases the total length of the core. That is, length of the machine increases. Now the ventilating system sometimes becomes unstable with respect to the quantity of cooling air flowing. That is, there is nothing to limit the air entering into the machine. So sometimes the ventilating system may become unstable with respect to the quantity of cooling air. So now the axial ventilation system. So axial ventilation system means it uses axial ventilating ducts. That is, ducts are provided along the axis of the machine. So this is one axial ventilating duct. This is another axial ventilating duct. That is along the axis of the machine. And if this axial ventilating ducts are provided only on the rotor, that system is known as simple axial system. And if axial ventilating ducts are provided both on the stator and on the rotor, it is known as double axial system. The axial system of ventilation is used for medium output and high speed machines. So we have said that there are two types of axial system. So here axial ventilating ducts are present both on rotor and on stator. So in this figure, a double axial system is shown. So air enters into the machine through this part. It flows through the axial ventilating ducts as well as through the air gap, and it leaves the machine through the other end. So this is suitable for machines of medium output and high speed. So because in high speed machines, a solid rotor construction is used. So we have already said that the rotor and stator cores are laminated. But in case of high speed machines, a solid rotor construction is used. That is, rotor is constructed as a single structure. It is not of laminations. So when it is solid, we cannot provide radial ventilating ducts. Laminations ulla caseilana nammal edakku spacer vechittu radial ventilating ducts ine produce cheyunu. But when the rotor construction is solid, there is no provision for providing radial ventilating ducts. So we have to go for axial ventilating ducts. So now, in order to increase the amount of cooling, holes can also be punched in the core. When holes are punched in the core, air can enter into this air will enter into that holes also. So cooling will be more effective. So now, what are the disadvantages of axial ventilation? So first one is non-uniform heat transfer. So see, air is entering through one side. This air will be cold. So cold air is entering into the machine. So from these parts, it will more effectively carry away the heat. But as air moves forward, it gets heated due to the losses in the machine. And the air coming to this side will be very hot, and it can carry away very less heat from these sides of the machine. So temperature at the entering end will be less. That is, temperature of the machine at the end through which the cooling air enters is effectively removed. Heat from this side will be effectively removed, and this side, heat from this side cannot be removed effectively. So temperature of this side will be very high compared to this side. That is what meant by non-uniform heat transfer. And second one is increased iron loss. So see, the ventilating ducts, axial ventilating ducts are provided on the stator and rotor cores. So ventilating duct is actually an air gap. It is a gap. So when such a gap is provided in the core, the amount of iron material decreases. Iron material is the gap provided. So amount of iron in the core decreases. Iron area decreases. So flux density in the core will increase. We know flux density is equal to flux divided by area. So when area of iron decreases, flux density increases. So when flux density increases, both hysteresis and eddy current losses will increase. So these are the disadvantages of axial ventilation system. And last one is the combined radial and axial ventilation system. So in combined radial and axial ventilation, both radial and axial ventilating ducts are used. So this is used for very large machines having a very high rating as well as very high speed turbo alternators. So used in large motors and turbo alternators. So in these machines, the temperature rise will be very high. So if we are going for axial ventilating ducts only, we have to provide a very large duct. So due to that, the iron area will be considerably reduced and iron losses will increase. So we have to go for mixed axial and radial ventilating system. So we will provide axial ventilating ducts as well as radial ventilating ducts. These are the radial ducts. And air will enter into the machine. It will flow through the axial ducts, radial ducts as well as through the air gap, and then it is pushed out to the atmosphere by the fan.